All right, guys, we're gonna go over the assignment 4 of CISC 5048. So this assignment has a lot of questions, so I'm gonna try to go over them fairly quickly. So 4.1, make a program that asks the user for a temperature in Fahrenheit degree and reads the number and computes corresponding temperatures in Celsius degree and prints the result alt. So this is pretty straightforward. What I need to take into mind is that I have to take in the user input and then print the result. So if I so I ran this in the Jupyter notebook cell. I was able to provide the corresponding Fahrenheit, and it will be spitting out a Celsius number. So I'll be trying to run everything here in the same Jupyter notebook rather than just kind of jumping around and running it in different places for consistency's sake. So for 4.2, modify the program so the Fahrenheit is read from the command line. So if it's read from a command line, mostly I think what's the common way, like a simple way, is to use the sys.argv and to start with the second argument of the argv. And I created the same function over here as a Python file. So this is going to be exactly the same as what's over here. And I'll be just rerunning this same thing with the input value of 98. And it'll be it'll be retrieving a Celsius number of 36.67 degrees. Now, obviously, you can use other more advanced libraries such as argparse, which you can customly define a parameter, and you then retrieve that from have the argparse parse the entire parameter over there. But for simplicity's sake, I'll just be using CISC for this entire assignment. 4.3 modify so the Fahrenheit temperature is read from a file with the following content. Now for the files, I'm just going to show over here 4.3. I'll have the file over here, and it'll be like a temperature with a dotted line and a space and a Fahrenheit degree based on what's shown in the prompt. So we'll get rid of, for the first 3 lines, it's not really showing me any results. So I'm just going to try to read through them without doing any logics behind it. And then afterwards, I'll be reading the 4th line and then split the result and taking out the first one. And then do the same conversion as I did before. I'll be running this and it will be giving me the result, the same result, correct result. 4.4 have several Fahrenheit degrees. This is going to be very similar to this one, the 4.3, except that we'll be running in a loop since we'll have multiple results coming out. So we have the similar thing. The first 3 lines will be skipped, and then starting from the 4th line, I'll be doing the same, same parsing over here. And what's different over here is that after all the parsings are done, I have to write the results out. And then so I'll be using the open write result. And then the intermediate result from the converted result is being saved in this res Python list as a tuple, and then they'll be written out of it afterwards. So I read over here, and the result is the file44out.txt. You can see over here, file4out.txt. It'll be looking like this. This is the result of output result of this function. Okay, 4.5, standard result from exercise 4.2 to try accept blocked handed potential errors. Now we'll be doing a try except exception box to catch the error that the input parameter is missing. So since we only use this is only the only part that's doing the input result. So I'll be running it over here. Actually, over here, let's see. I think it's I think it just ran this the same way. It should have been input.num, and this would have been fine. Yeah, I think this is the correct way of doing this. So we'll be doing try and to get input num, and then we'll be using that. If it fails, if it's missing, it's just going to return and it's just going to return nothing. For 4.6, is for eval functions. We'll be entering an input over here. I entered all of these here with an integer, a float number, which is the same as a real number, and a complex number, a list, and a tuple. And it'll be giving me a result with showing me the types over here. 4.7, writing a program store result of applying the eval function to first command line argument, print out the resulting object and its type. For A, let me go over 4.7 for better clarity. The program print out the resulting object and its type. Yeah, so I think A just lets you write the function. So will be this is the first condition, means that if you have to, just letting you know that you have to put in at least one command, and it will parse the command and print out the result as well as types. So going for B, I'll be going through all these input parameters. You can see that there it's showing that the result as well as the types. And then we'll have a object CML. This is a part C. Oh, for part C over here, when I type in that this is a string, it's going to show an error that this is not defined because it's not really expecting like a string over here. It's not expecting like this as a string for evaluations. So we'll have to, if you want to change that, you have to, because this is going to be a name error, the name is not defined. So we can get rid of it with a try except on the name error. Then if you can do whatever logic you want. You can choose not to do the eval and instead of just getting the string, and that would have been fine. 4.8, the purpose in standard libraries. Okay, I'm just gonna show 4.8 and 4.txt, and the 4.8 is just a docx file, and let me see if I can open this. Yeah, you can't really open this. You have to use the open the Word, but what's shown here is that you can't really run a docx file as an executable as a Python script, but you can do that with the txt file. Yeah, for 4.9, let's see, for 4.9, and consider simplest program for evaluating this function, modify it. And so I'll be doing that. You'll be taking in two inputs. You can type in two inputs, one for V0 and one for T. And you can just use the input over here and then convert that into a float number. And you run this script and it'll be getting you this number. And 4.10 is to modify the program so that VO and T are read from command line. And we can see that we can use the sys.argb as we were using before. Well, the first argument is going to be the V0 and the second argument is going to be the T number. So we'll be doing the same thing over here, 3 and 0.6, and it will give us the correct, exactly the same value. 4.12, the test of the T value read from the program lies between 0 and 2. So this is going to be a condition over here. If the T value does not really fit this condition, you're not going to run the rest of the script. You're just going to print a message and exit. So same thing as we were doing before, except on this stage, you'll be running a if statement. If it doesn't, the logic says if it doesn't fit within this boundary, it's going to say T value is out of bound, and it's just going to return that. Otherwise, you do the rest of the logic and print this out. The last question, this one's a little bit confusing to me, to be completely honest. But I think the idea is to read in a file and count the number. I'm not exactly sure what specific meant here. I think it means distinct words, but also number of total words. Even though if we were to have distinct, this is only like 2 distinct words, to be fair, unless you count this, then you get 3. But I just created a, what is it? Let's say 3 distinct words. I'll put output here as well for distinct words. What you do is that you input the path. This is the path to the file, and I add a result. This is for intermediary storage. I use the default tick because you can have like a default value when you do a get on one of the key, and if the key doesn't exist, it's gonna create one for you with a default value of 0. So that makes things a little bit easier code-wise. So we'll be reading line by line. While we have lines, we'll be, first of all, getting rid of excess space, and then split this based on empty space, which I think this is how this is structured. And then parse and then add this word into this result dictionary, where the value is the number of times it repeats. And before we go into the next line, so now the words over here will be the number of distinct words, and that will be the number of keys, the length of all the keys in this dictionary. While the total number of words will be the sum of all the values. So I ran this file over here. The countword.py file is exactly the same as this. It will be giving us the results over here. So yeah, that is everything. That is all the everything for the assignment 4.